Feed efficiency. There's never been a better time for us to consider feed efficiency, given the increases in feed costs we've seen over the past while. It's not always considered a key measurement used to assess the performance of flocks. And this presentation aims to give some reasons as to why feed efficiency is important and why we should be more aware of it. So before we consider feed efficiency in more detail, it might be worth considering how feed efficiency has developed in other poultry species over the years, and also how feed efficiency is likely to progress going forward. I've been very fortunate to be involved in all three species and seen the rate of improvement of conversion of feed to their respective end products, whether it be broiler or turkey meat or eggs. The rate of improvement has been really impressive over the years. A great example showing the improvement in feed efficiency is the broiler industry, where use of technologies such as feed stations has allowed more accurate determination and selection for feed efficiency. This has led to an improvement in FCR for a Ross 308 broiler of 2.5 to 3 points per annum, or 1 to 2% improvement per year. This trend is likely to continue into the future with a planned genetic improvement to a 1.3 FCR by 2024. It's understood that there are some broiler integrations and they are already achieving FCRs of 1.3 in the field, and they also aspire to FCRs of 1.1 in the future, which is really a remarkable level of feed efficiency to achieve commercially. Of course, one of the main benefits of these improvements in efficiency is economic. The improvement in FCR from 2014 to 2024 equates to about a 4.5% increase in margin per bird, which is really quite a substantial economic improvement through genetic progress in feed efficiency. This shows the improvement in broiler FCR and live weight in the US industry over the past 50 years. Live weight, shown here in blue, has increased, and FCR to a fixed live weight has also improved significantly over that time period. And this is really interesting data because it shows that the improvements that we've seen genetically are actually being realized in the field. Feed efficiency is also important from an environmental point of view. If we were to compare today's broiler with one from 15 years ago, the associated improvement in performance would result in a reduction in land use. This would be through improvements in livability and feed conversion ratio, so that a 2.5 kilogram broiler will consume approximately half a kilogram less feed. This would equate to 37% less agricultural land required for the production of that broiler feed, and 10% less houses for the same number of broilers. In turkeys, we've seen a very similar trend in live weight and FCR as we saw in the broiler sector. Live weight has increased impressively over the last few years with continued improvements in feed conversion ratio. However, our committed genetic progress, this is the progress that we know is in our existing program, we can expect to see continued improvements in feed conversion ratio. And beyond that period, we can see that in our planned genetic progress, we will see continued improvement in feed conversion ratio and also live weight. And finally, to the layer, this shows the egg mass output and feed conversion ratio of the highline brown bird over the last while. And we can see that egg mass output has increased tremendously, but along with that, we've seen a very steady improvement in feed conversion ratio over that time period. So really the laying bird is showing a very similar trend and just as impressive genetic gain as we have seen with broilers and with turkeys. This shows the main traits we select for in our breeding program. The percentage relates to the emphasis of each trait in our selection process. The main emphasis is on production, shell quality, egg weight, but there's also a significant amount of emphasis on feed efficiency. In our breeding program, feed intake is recorded for each individual at later ages than broilers and turkeys. Feed intake is also related to egg mass output and also to body weight, to give what we call a residual feed intake. This index makes sure that we select birds that are not just efficient but also highly productive. The graph on the right shows a positive relationship between egg mass output and feed intake. We want efficient birds, but we don't want to select out birds that have a low feed intake but not that productive. We want to select birds that have a good egg mass output as well. So there really is a balance in selecting for not just efficiency but also productivity. Annual genetic improvement targets for hyaline brown layers are shown here for some of the main traits. Although egg numbers, shell strength and egg weight are expected to improve, feed efficiency is expected to continue to improve by 0.4 of a gram per egg or 5 grams per dozen eggs. So it's not as dramatic as what we've seen in turkeys and broilers, but still lots of potential. If we aim to exploit this genetic potential, how might we go about it? Well, first of all, we need to know how to measure and express efficiency. Put in its most basic form, feed efficiency is really just a measure of how well a flock converts consumed feed into egg mass or numbers. In this case, we're referring to the amount of feed being converted to 1 kilogram of egg mass. So a typical feed conversion ratio might range between 1.9 to 2.1 kilograms of feed for every 1 kilogram of egg mass output. However, there's lots of other ways upon which feed efficiency can be expressed. There are 3 different ways of measuring feed efficiency. Feed conversion rate, which is what we've already described, is the kilograms of feed consumed divided by the kilograms of egg mass produced. Feed utilization, which is the reverse of feed conversion rate, which is the kilograms of egg mass produced divided by the kilograms of feed consumed. And then finally, feed consumption per dozen eggs, which is the kilograms of feed consumed divided by the dozens of eggs produced. The way feed efficiency is measured is quite dependent on the objectives of the business. However, regardless of how feed efficiency is measured, the key point is that even small changes in efficiency at any given feed price will have a significant impact on financial performance. Take, for example, a free-range flock producing 345 eggs to 76 weeks of age. With a feed intake of 125 grams per bird per day, FCR is estimated at 1.83 kilograms of feed per dozen eggs. This results in a feed cost of just over £14.5 per bird. That's based on an average feed price of £277 per metric ton. So assuming the same egg output, an improvement in FCR of just 8 points through a 5 gram reduction of feed intake results in a cumulative feed intake reduction of 2.1 kilograms. Now this results in a net reduction in feed cost per bird of just over 50 pence, almost 60 pence per bird. And this really isn't an insignificant reduction in feed cost. So even a fairly modest improvement in FCR can equate to quite a substantial improvement in feed cost. And very similar estimations are made by the British Free Range Egg Producers Association website, where there's a calculator that estimates the cost consequence of feed intake. And in this estimation, the difference in 5 grams feed intake is very close to what we've already estimated. So really the impact of feed intake and FCR is really quite substantial. The same exercise has been conducted on a colony system with an egg mass output of 21.1 kilograms per bird to 76 weeks of age. Feed conversion ratio here has been estimated as a kilograms of feed per kilograms of egg mass. Similar improvement in feed conversion ratio results in a reduction in feed cost per bird of around about 57 pence per bird. So very similar to what we saw with the free range exercise is that even a modest improvement in feed conversion ratio can result in a substantial cost saving. So the impact of feed conversion ratio is quite significant based on relatively modest feed costs. But given the projections for raw material prices, what about a situation where feed costs were to rise even further? The 2 graphs here show wheat and soybean meal prices, and they, as we all know, have increased very significantly, and the forecast doesn't look particularly good either. The graph on the right shows feed prices increasing from left to right to reflect these increases in raw material prices. Feed cost per bird is estimated both at a high and low feed conversion ratio. And as we would expect, feed cost per bird increases as feed cost per ton increases. Not surprisingly, an improved FCR results in lower cost per bird. However, as feed cost increases, the potential feed cost saving per bird increases. So the differential between a low and a high feed conversion ratio at the lowest feed cost is about 58 pence per bird. As feed cost increases, the differential between FCR, low and high FCR, increases to 71 pence. So in other words, optimizing FCR becomes even more relevant as feed prices increase. So we've identified that FCR is important for us to try to get an understanding of. Now we need to take a look at what factors are going to influence FCR. So there are many different areas that can impact on feed efficiency, and these can be categorized into different areas like feed quality, health status, and management. And I think one of the real surprises about feed efficiency is that there are so many areas that can impact on feed efficiency. And it's not just the obvious ones like, for instance, nutrient density, feed quality, or house temperature. There's lots of other areas that perhaps we might not have given too much consideration to that can have quite a big impact. Even management related areas. So I'm going to cover on a few feed quality related areas, one or two management, and then my colleague Greg Selliers will handle some of the more health orientated aspects. So I think one of the key things here is there's lots of different aspects that we need to cover, and that indicates that there's lots of opportunity for us to improve feed efficiency. There's probably three main components of nutrition that we need to consider from an efficiency point of view. That's raw material digestibility, so how well can the bird actually digest some of these materials, the nutrient spec of the diet, that's probably quite an obvious one, and then of course the nutrient absorption by the bird. How efficient is the bird's system in actually absorbing the nutrients that it needs. And those are kind of aspects that Greg Selliers will probably be covering within a different context. Feed efficiency starts with an accurate knowledge of the quality of raw materials, allowing for more precise adjustment of the feed formulation to meet the nutrient specification of the diet. This graph shows the results of a survey conducted on UK wheat. It shows the average crude protein analysis results over time. As you can see, crude protein analysis of wheat tends to change quite significantly from year to year. For example, the average analysis results for 2020 look to be significantly higher than 2019. This is quite a good example of a component we might need to take into account in our formulation process. These are results from the same survey, but looking at crude protein analysis and estimated energy density of wheat by region in 2020. The differences across the regions are quite significant. Wheat in Scotland is analysing out quite differently to wheat that might be sourced from the east or the west. And it's very important that these types of differences are taken into account. Taking these extremes and differences from year to year and region to region, and also considering wheat as such a significant component of most diets, it's important that we take these types of differences into account. A diet based on a 12% crude protein content wheat has quite a different crude protein and amino acid content relative to one which is based on a wheat with a crude protein content of 9%. That's of course making a really big assumption that no adjustment in wheat density is taken into account in the formulation process. However, the key point is that from an efficiency point of view, birds that are going to be fed on these different nutrient densities are going to convert their feed to egg mass quite differently. So we have to take these types of extremes and differences in raw materials into account and make adjustments in our formulation process from time to time. After all, most raw materials aren't constant. They do tend to change, and some tend to change more than others. We need to make sure that we've got the right feeding program in place. The right nutrient density at the right stage in lay is going to optimize that efficiency. So it's important that we are not just feeding the birds to optimize production at key stages like at peak, but we're also making sure that we are catering for the birds to maintain very high persistency later on in lay. This is a good example of a high-performing flock. Its hen day production is 96% at 50 weeks of age and persisting very well. And this is something that we see in a number of flocks that are persisting as well as this, if not better. Conventionally speaking, we would have moved these birds onto a lower nutrient density diets at this stage in lay. However, because persistency is so much higher now than in the past, it's necessary for us to keep these birds on a higher nutrient density diet to support that improved egg mass output and egg numbers. If we move these birds onto a lower nutrient density diet prematurely, there's a strong likelihood that productivity will be affected, but also feed efficiency will be negatively impacted upon. Bringing these birds onto a much lower nutrient density diet means that they are going to be struggling to get the nutrients that they need. Their feed intake is likely to increase and their feed efficiency will deteriorate. So it's important that we maintain a reasonable nutrient density to meet the birds' higher nutrient requirements in this period relative to what we might be used to in the past. It's all very well recommending a higher nutrient density diet to support persistency and feed efficiency, but will this approach be cost effective? And is there a point upon which achieving better performance through nutrition starts to become cost prohibitive? So in an attempt to try to answer this, we've referred to some work which is conducted on hyaline brown layers, looking at the impact of different nutrient densities on performance from 24 through to 59 weeks of age. Nutrient density was increased from the first through to the last treatment at very similar increments. So the results are shown here for both egg production and egg size. The nutrient density is shown here in the bottom axis, from the lowest through to the highest treatment. And we can see that as nutrient density increases, there's an increase in production all the way through to the second highest nutrient density. Egg weight increases from the lowest through to the highest nutrient density treatments. So overall, we can see that birds are very responsive to nutrient density, both from a production and egg weight point of view. So the question now is, do we see the same degree of response in terms of feed efficiency? Feed intake, shown here in grams per bird, decreases with increasing nutrient density. This is very much what we would expect to see. Layers tend to adjust their feed intake to energy density, not always precisely, but in this assessment it was very consistent. So we've seen an increase in productivity with increasing nutrient density, a decrease in feed consumption. So we should see an improvement in feed efficiency as well. So feed efficiency looks to be very responsive to nutrient density. And this is important because it shows that there's real potential for feed efficiency to be manipulated through nutrient density. We referred to the impact of a change in feed conversion ratio a few minutes ago, and we showed that just a few points improvement in FCR results in a significant reduction in feed cost per bird. So we should now go and see how the economics look at these different feed efficiencies. The formulation cost per metric ton was estimated for each treatment and also intermediate nutrient levels in order for us to get a picture of the impact of increasing nutrient density and economics. And of course, as we would expect, with that increase in nutrient density, there was an increase in formulation cost. Feed cost per bird was estimated and increased as nutrient density and feed cost increased. Also shown here is the revenue per bird. This is the total revenue over the time period of the study. As nutrient density increases, production increases, and so too does revenue. So revenue per bird was optimal at the intermediate to higher nutrient density levels. When we superimpose revenue over feed costs, we can identify the point upon which margin is optimized. The point of maximal differential between cost and revenue is at the intermediate to higher nutrient density levels. So although feed costs may be increasing with increased nutrient density, revenue is also increasing, but to a greater degree. So if efficiency and margin is our key objective, then feeding nutrient densities closer to these levels is likely to achieve that aim. Now, many customers don't choose efficiency and margin and opt to try to minimize feed costs per bird by feeding lower nutrient density diets. This strategy is successful in that feed cost per bird is reduced. However, revenue per bird is also likely to deteriorate, resulting in lower margin. So the key message here is that if our goal is to optimize margin, then we ought to feed the bird to achieve this. Based on the feed costs that were used in this exercise, feeding lower nutrient density diets results in lower efficiency and reduces feed cost per bird. However, feeding the higher nutrient density diets increased efficiency and also resulted in higher margin. However, what if we are faced with a higher feed cost base? Does the pursuit of efficiency still pay? The red line here represents feed cost per bird when feed cost per metric ton has been increased by over 15%. As you can see, even though feed cost has increased, the point of maximal differential between revenue and cost is still at the same point. So based on this study, even at higher feed costs, it looks as though achieving higher efficiency through nutrient density still pays. We've spoken about the importance of feeding the right nutrient density to achieve the bird's potential for efficiency. We also need to consider the physical quality of the feed. After all, there's no point in investing in nutrient density if the birds aren't going to find the feed appetizing. This is a sieving analysis of a mash feed. The particle size is given as a percentage of the total sample. We don't want too many small particles. Birds don't find these appetizing. And at the other extreme is that we don't want too many large particles, which might result in birds selecting out large particles, and that's not ideal from a nutrient intake point of view. We really want to have a balanced nutrient intake, and selecting out large particles isn't really going to achieve that. We want most of the particles falling between 1 to 3 millimeters. Remember, the raw material components in the diet, they're also going to influence the particle size of the finished feed. So it's better not to make too many sudden changes in the raw material levels. Try to keep the diets homogeneous and also try to maintain consistency as much as possible. We've spoken about quite a few key areas related to feed, and I hope we've conveyed the potential to influence feed efficiency through nutrition. We've not, however, spoken about feed additives, such as enzymes and others. The application of some of these technologies are a given in terms of feed efficiency and financial benefits. There's just so much ground to cover in a webinar such as this that it's not been possible to really cover this very important area. However, I'd strongly encourage you to try out new technologies to achieve better efficiency. We need to move on now and consider some of the management-related areas that can impact efficiency. So good management is one of the keys to achieving efficiency in rear and lay. A good example are the conditions during incubation, which can sometimes impact growth in FCR. And the same can be said for brooding practices. And it can sometimes be overlooked that management during these periods can have a big bearing on feed efficiency for the remainder of the bird's life. So it's worth us looking at this in a bit more detail. This is data that shows the impact of conditions in the incubation process on broiler feed efficiency. And it shows that feed conversion ratio at 21 days of age was significantly compromised in birds that were derived from hatching eggs that were kept at higher incubation temperatures. And it shows that overheating embryos in the later stages of incubation, even for a short period, can have a pretty negative impact on gut development. And of course, that's going to impact then on nutrient digestion and absorption. So what we do within the incubation process can have a lasting impact on feed efficiency for the rest of the bird's life. The brooding period is an important time in the bird's life, as this is when development of the intestinal system is optimized. If the chick misses out in developing the gut in this period, it's unlikely it can make up for it later on in life. So a well-developed gut is likely to be an efficient gut for the remainder of the bird's life. This shows what we want to see. very well developed villi with lots of surface area to absorb nutrients. The images over here on the left show the impact of a combination of incubation conditions and access to feed on intestinal villi development. Villi from chicks from eggs incubated for a prolonged period and fasted had poor villi development relative to those that underwent normal incubation without any fasting. This will have an impact on nutrient absorption and then of course feed efficiency. Now we're all really aware of some of these types of images showing the impact of early nutrition on gut villi. However, what we might not associate is the impact of stocking density on gut development. Chicks placed at 1.5 times normal stocking density had much poorer gut development than those which were placed at normal stocking density. So where access to feed and water becomes an issue, we can expect the gut to be compromised. So it's really important how we handle these birds and how they are managed right from the very beginning of life. The environment or the conditions upon which the flock are housed can also play a part in feed efficiency. These graphs show estimated energy requirements and feed intakes at different temperatures. In white, the estimated energy requirements are shown through production, and in blue, the associated feed intakes. At moderate temperatures, the bird's energy requirement will be somewhere between 1.3 and 1.4 megajoules per bird per day at peak production. If feed energy density is somewhere between 11.6 to 11.8 megajoules per kilogram, then feed intake is estimated to be between 110 to 120 grams per bird per day. However, at lower temperatures, the bird's maintenance requirement is likely to be higher. In this case, energy requirement will be increased by almost 0.1 of a megajoule per bird per day, again at peak production. As a consequence, the bird is likely to increase its feed intake to meet this higher energy demand. At higher temperatures, however, we can expect the opposite effect, a lower energy requirement and lower feed intake. The images show free-range birds in extreme situations, but the same applies for conventionally housed birds. The birds will eat dependent on the conditions that they are exposed to or housed in, and this is obviously going to have an impact on overall feed efficiency. And here we can see the impact of different temperatures on cumulative feed intake, egg mass, and feed conversion ratio. It's assumed that egg mass output is maintained across these different temperatures. With different feed intakes, FCR is very different across these different temperatures. Keeping birds at low temperatures will be less efficient than those kept at high or even moderate temperatures. Now, I'm not recommending keeping birds at high temperatures due to the risk of other potential issues such as floor eggs or ventilation issues occurring. But it is important to try to keep to a moderate temperature and try to keep to this temperature consistently. Maintaining a consistent house temperature is important to avoid temperature fluctuations, which will obviously impact on feed intake, which is going to have a negative impact then on feed conversion ratio. The ventilation system should be capable of maintaining a comfortable house temperature, even when outside temperatures range from -3 to +18 degrees centigrade. We're also aiming for a uniform temperature throughout the shed all the time. We're aiming to try to have less than 0.5 degrees centigrade variation in temperature across and down the length of the shed. And in my experiences, that can very often be a challenge. I very often see house environments where parts of the house can be particularly cold relative to other parts of the house, which can be excessively warm. And the energy needs of birds in those two different extremes can be very, very different, as we've just demonstrated. So those birds' nutritional requirements will be different. So as a nutritionist, it's very difficult to cater for birds that are experiencing such differences in their environment. So really what we're aiming to try to do is maintain that consistent, comfortable environment all the time. That's going to ensure that the nutrients that we provide those birds that we've designed in our feeds are really adequate for the birds' nutritional needs. Lighting, I think, has got a very important part to play in efficient feed consumption. If the bird can find its feed efficiently, it's going to expend less resources on trying to find feed, And also, if the feed is adequately illuminated, it can consume the feed that it needs efficiently every day. So I think lighting has got a very important part to play. We're looking for the right intensity, and we're looking to have all of the feeding systems and also the drinking systems adequately illuminated. Feather cover also has an impact on the bird's nutritional needs. Some birds lose feathers due to feather pecking, poor beak treatment, or just abrasion. And of course, feathering is a very important welfare aspect, but we also need to consider it from the point of view of the bird's nutritional needs. Poor feathered birds have higher feed intakes to compensate for the amount of feed energy lost as heat. And this is even more important if birds are kept at cooler temperatures below 20 degrees centigrade. This shows the impact of the degree of feather cover on estimated energy maintenance requirements by the bird. As the degree of plumage decreases, given here as a percentage of a bird with 100% feather cover, the bird's maintenance requirements increases. So as feather loss increases, feed intake is also expected to increase by up to 10 to 13 grams per bird per day of additional feed at 50% feather loss. From an FCR point of view, this is very significant. This will of course impact on feed cost per bird, which, if you remember from our first calculations, is very significant. In fact, this estimation is even more significant than what we saw at the beginning of our session. So it's important to consider maintaining good feather cover throughout the lifetime of the bird. A poorly managed feeding system or poorly regulated quantities of feed within the feeders can result in feed wastage, and of course that's going to impact on feed efficiency. We've also spoken about the importance of particle size and making sure that the feed is presented adequately within the feeders. Water intake is also important. It's correlated with feed intake, and any decrease in water intake is going to impact on feed intake. So we need to make sure that both feeders and drinkers are adequately managed for optimum efficiency. We're now going to start talking a little bit about the impact of health on feed efficiency. We know that the environment has a big part to play in how much stress the bird can encounter. And we know that during a stress event, that the bird produces hormones that can impact on feed retention time and passage of feed through the gastrointestinal tract. And that, of course, is going to reduce nutrient absorption, which as a consequence is going to have a negative impact on feed efficiency. So the environment that we create for birds can indirectly have an impact on overall feed efficiency. During a stress event, injury, or an infection, the bird's immune system becomes activated. The bird's macrophages and T cells produce cytokines, and these are proteins that kickstart the immune system to start doing its job. The liver increases in size and acute phase proteins are produced, which then go on to do their job in countering the disease challenge. From a nutritional point of view, there's an expenditure in the immune system becoming initiated and doing its job. For instance, macrophages require 10 times more energy than cardiac muscle. Production of acute phase proteins requires breakdown of a significant quantity of muscle protein. So we need to bear in mind that when the bird encounters these types of stresses or an infection, that there is a significant diversion of nutrients and resources away from productive purposes towards dealing with this challenge or this stress. It's been shown that birds challenged with an E. coli infection have increased requirements for sulfur amino acids and tryptophan relative to unchallenged birds. It's been suggested that the increase in requirement level can be as much as 20 to 30%, which is a very significant increase in requirement for some essential amino acids. And this is for a condition which is not uncommonly seen in the industry. In order to cater for the bird's increased requirements during a disease challenge, a higher nutrient density diet could be provided to the flock. The diet on the right-hand side has increased levels of amino acids to deal with the increased requirement levels for some essential amino acids. We see these types of stress diets used in some parts of the world, and they do seem to help the flock recover that bit quicker from a challenge. There is, of course, a cost impact of providing an increased density diet. the cost of the increase just in amino acids alone is really quite substantial. But perhaps by quantifying the cost of disease challenge in this way reinforces the importance of disease prevention. And this is an area which my colleague Greg will be covering in a few minutes. So we've covered very many areas related to both feed quality and also management. And I hope that there's something in here that has been of interest to you. I'd like to hand over to my colleague Greg, who's going to be covering some more health related areas.